Today, we'll continue our review of basic Aeroseal product knowledge by clearing up common application misconceptions some dealers and homeowners have. The first common misconception is that Aeroseal coats the inside of the ducts with sealant. Not so. At the end of the typical job, only a few ounces of sealant has been deposited inside the ducts. The inside surfaces of the ducts do not get all sticky. This is because the sealant fog is very lightweight and stays suspended in the air until it finds a leak. Then the sealant flows out through the leak, initially leaving some behind only at the edges, and then building up until the gap is sealed. At the end of the process, we stop injecting additional sealant, yet we keep the fan going on for several more minutes to continue sealing. This purges the remaining fog through to seal the final leaks or continue out of the ducts if the leaks are no longer sealing. So although we sometimes say that Aeroseal is kind of like Fix-A-Flat, but for ducts, the analogy is not perfect. Fix-A-Flat does leave a sticky coating everywhere inside a tire. Aeroseal does not. A better automotive analogy is the radiator stop leak, which also works by having the sealant find its way just to the leak, without leaving any significant residue elsewhere in the radiator. Now, having said that, there is one place where sealant can build up, and that is right across from the injection point, like in this plenum, simply because the sealant fog impacts the other side of the duct at some velocity and splatters a bit. Good practice is to place temporary masking in this area when setting up and to remove it and any sealant that built up during the tear down. When doing reverse injection, where the sealant travels backwards into the system through supply boots or return cans, it's also good practice to line the boot and the first foot or so of the duct with sacrificial masking as well. The next common misconception is that Aeroseal only seals sheet metal ductwork. This is absolutely not so. Dealers successfully seal all kinds of ductwork every day. Flex duct systems, ductboard systems, internally lined metal duct systems. The sealant finds and seals leaks by following the escaping air into the cracks and gaps and deposits itself at the edges where there is a pressure drop and then gradually builds a plug and plugs the leak. The duct material itself is almost irrelevant. Now, having said that, different kinds of duct materials do present different opportunities and different application challenges. All flex duct systems, whether standard pressure or high velocity, do tend to start out tighter and seal very quickly with not very much sealant. Yet, they also tend to be more prone to have complete disconnects that need to be found and mechanically reattached as part of the project. And typically they have significant boot leakage. Ductboard systems and internally lined metal duct systems do take a bit longer to seal and they do require more sealant, but they do seal. There's also a greater risk of a section of poorly assembled ductboard opening up due to high pressure created during the sealing process. So your Aeroseal technicians need to be fully trained on the many application techniques and how to operate the software and so on to efficiently deal with what they run into in the field. If your team needs more technical training or if you simply have technical application questions, contact dealer development or tech support and to arrange additional help. As an Aeroseal sales representative, stay in communication with your installation crew to better understand what you should be looking out for in your market that would need to be taken into account when quoting a job or controlling the client's expectations. There are two specific situations, types of duct systems, where extra client communication is definitely needed. The most common is when dealing with building cavity return systems, where the house's wall and floor cavities form part of the return air system. They can be sealed, but it is more involved than sealing completely ducted systems. Building cavity returns are a pretty big and complicated issue, so we'll dive into that as the sole topic of our next 3 lessons. The other type of challenging duct system is one in which the supply ducts are embedded in or under the concrete slab. While not present in every market, under-slab ducts made of metal, cement asbestos pipe, or even cardboard sonotube are pretty common in some parts of the country. The misconceptions are that A, duct leakage isn't a problem with sub-slab ductwork, and that B, Aeroseal won't work to seal any leaks anyway. Okay, so this one is a bit complicated. First, ducts in concrete slabs usually do have some air leakage that can be worth sealing. While air can't travel through solid concrete, air does travel readily through porous sand, gravel, and dirt. There are often many spots where air leaks do occur, especially if the original pipe has degraded, metal pipe rusts, for example, or if there are any cracks in the concrete, or if the ducts weren't completely surrounded by concrete when it was poured. Another common leak is the gaps around the supply boot to concrete connection, boot leakage. Another is where the counterflow HVAC equipment, typically the AC coil, sits on the concrete slab. If there's any question as to whether there's sufficient leakage to warrant sealing, doing a duct leakage test first will give you and your client the answer. Now, apart from causing energy waste and discomfort, these underground air leaks can be a common cause of musty odors, unhealthy radioactive radon gas, and even bugs coming up into the house. Having said that, know that the general industry consensus is that the best solution with old, deteriorating underground ducts is to abandon them, seal the openings, and find a way to run a new duct system overhead. This is especially so if the ducts are deteriorating cement asbestos pipe or cardboard sonotube, or if there's any evidence of past water intrusion, and especially if there's standing water in them. Now, unfortunately, a new duct system is always going to be a big investment for the client, and in some houses, major renovation would be needed to run new ducts. So, while it's not strongly encouraged, dealers have successfully applied Aeroseal in the past to slab ducts, notably if the ducts were made of metal, there was no evidence of totally collapsed ducts, and that they were cleanable, and there was also a low risk of future rising water. It's important to be aware that the Aeroseal sealant will not keep out rising water, and the Aeroseal manufacturer's warranty does not apply in cases where water is soaked into or pushed against the sealant, which can happen in some underground duct systems. The client needs to be fully informed in writing of all the pros and cons of choosing to apply Aeroseal in a sub-slab duct system. If when you look into the ducts you see signs of past water intrusion, like dried mud or a water line halfway up the sides, or actual water with little bugs floating around in them, Aeroseal is really not recommended. If it happened before, it might happen again. On the other hand, if the ducts are dry as a bone, there's no sign of past water intrusion, Aeroseal is likely doable, with the written warning that any future rising water incident will likely cause the sealant to fail and the warranty would be void. If you have further specific questions on applying Aeroseal to this type of ductwork, contact your dealer development account manager. The issue of durability brings up another pretty common misconception, that Aeroseal only lasts 10 years. Wrong. The sealant carries a manufacturer's warranty of 10 years, but it is expected to last the lifetime of the duct system. Kind of like your new car may have a 100,000 mile 5-year limited warranty, but will likely still be on the road in 10 or 15 years. A bit of background. When the sealant was originally formulated, Lawrence Berkeley Laboratories did accelerated aging testing on it, where over the course of a few years it was subjected to the equivalent of 40 years of heating and cooling cycles. And at the end, the sealant was just as rubbery, stretchy, and cohesive as it was at the start. It's interesting to note that they also tested conventional gray cloth rubber adhesive duct tape at the same time. It failed in just a few months. Duct tape is a great temporary tape, but the last place you ever want to use it is on air ducts. Another related set of misconceptions are that the Aeroseal sealant needs to cure, or takes a long time to dry, or gives off the craft glue smell for a long time. None of these are so. The sealant itself is in the plastics family of vinyl polymers, similar to white craft glue, but stronger and stretchier. The liquid that comes in the jugs that goes into the Aeroseal machine is a mix of molecules of the plastic sealant, about 35%, suspended in water, about 65%. The main function of the Aeroseal machine is to separate the two and drive off the water so that the dry adhesive sealant particles can float their way to the leaks. It's fair to say that the sealant is already dry by the time it sticks to the edge of the leak or to its neighboring particle. At most, within a few hours, any remaining surface water has evaporated. And there's no curing of the sealant, as no chemical process is taking place. It's okay to start the system back up by the time all the teardown has been completed. Typically, any odor in the living space goes away with some house ventilation and once the air handler is turned back on. There is one instance where odors have been known to develop, and that is when the client had a UV light in place which intentionally created high levels of ozone. High ozone levels can cause the vinyl sealant to break down and release an odor. The problem has been solved in the past by simply replacing the ozone-creating bulb with a standard UV bulb of a different light frequency. Many health authorities say humans shouldn't breathe ozone anyway, as it also can break down lung tissue. The client will likely smell the Elmer's glue smell while the sealing is happening and until it dissipates. This brings us to another common misconception, that any visible sealant fog in the air means something is wrong. Not necessarily. This is really a matter of degree regarding what is acceptable. Some fog is almost always going to be visible in the air where the ducts are located. It's pretty much inevitable, as some sealant has to escape through the cracks while sealant builds up in the cracks. The leakier the ducts, the more fog is going to be present. This isn't a big concern when the ducts are in an attic or crawl space, but definitely is when the ducts are inside the house, as we typically see with basements. The normal application process includes multiple tactics to capture this fog with air scrubbers, or to ventilate it out using fans so that it doesn't settle on surfaces in the living space. Now, when ducts are in crawl spaces and attics, a smart play is to keep the windows closed and use some kind of fan to blow a bit of air into the home to create a positive air pressure, which keeps any attic or crawl space fog from sneaking into the house. Okay, so that's it for today. To recap the key points from this lesson, Aeroseal does not coat the inside of the ducts with sealant, just the leaks. Aeroseal seals sheet metal, flex duct, ductboard, and internally lined ducts. Aeroseal can seal building cavity returns. Duct leakage can be a problem with sub-slab ductwork, and Aeroseal is sometimes a suitable solution. Aeroseal's product warranty is 10 years, however, it was subjected to accelerated aging testing equal to 40 years of use and can be reasonably expected to last the lifetime of the duct system. And finally, the Aeroseal sealant does not need to cure. It is already completely dry, or it dries within 2 hours, and it does not give off the craft glue smell once the project is completed. Thanks for being an Aeroseal dealer, and we'll see you on the next lesson.